I'm from Gould Instruments. We're here today at the TAFE facility at St Leonard's, North Sydney. They've kindly let us do some filming here to demonstrate how to test various types of backflow prevention devices. I myself am not a qualified plumber or backflow tester. I'm purely demonstrating how to test these devices with the latest Australian standard, which is AS2845.3 2020 version. And we're also under the guidance of the Backflow Prevention Association of Australia today, who are supervising the testing to make sure that we're adhering to the standard. So what we're going to do for a start is we're going to test a double check valve. So the first thing we do is make sure that the upstream isolation valve is open so that we have water supply to the device. So the next thing we're going to do is we're going to bleed out any air and impurities that might be in the lines. So this is test tap number 1, test tap 2. We're just opening the valves to get rid of any impurities in air and close it properly. And test tap number 3. Okay, so we've got rid of any air and impurities that might be in there at the moment. Right, the next thing we're going to do is we're going to close the downstream isolation valve. We are going to hook the high pressure hose of our digital test kit to test tap number 3. So what we're doing here, the first part of the test is to test the integrity of the isolation valves. So the first thing we're going to do is we're going to make sure that valve A on the test kit is open, valve B and C are closed, and we're slowly going to open test tap number 3. Then we're going to bleed any air and impurities out of this gauge and the hoses by opening valve B, close valve B, open valve C, close valve C. That ensures that there's no air in the system, because air is obviously compressible, so we want it full of water with no air. So they're both been bled now. So the next thing we're going to do is we're going to close the upstream isolation valve and we're going to observe the pressure. We must always drop the pressure at this stage so that we can observe if the pressure is rising or falling to determine if the isolation valves are leaking or not, even on the digital gauge. In this case, we have 185.6 kPa and it is solid. So that means that both of the valves are holding. If you had an analog gauge, which is ranged 0 to 100 kPa and then it goes into over range, you would need to drop it below 100 kPa, observe the reading, and same thing, see if it's rising or falling. So in this case, we don't have a rising or falling pressure, so it means the valves are okay. Now, if you did have a change in pressure, rising or falling, you would close valve test tap number 3, remove the high pressure hose. If you open test tap number 1 and observe any continuous water flow, that would mean that the upstream isolation valve is faulty and requires repair or replacement before you go any further. But in this case, it's not flowing. Then you can open test tap number 3 and observe if any water is flowing there. If there was, that would mean that the downstream isolation valve is faulty and requires replacing or repairing before any further testing is performed. So in this case, our valves are okay, so we close test tap number 3 and move on to the next part of the test. Right, continuing on with our double check valve, we've proven that the upstream and downstream isolation valves are both sound, they're not leaking, so that's good. If they were, you'd need to replace them, particularly the downstream. The next thing we're going to do is clean and check the Y strainer where fitted. In this case, there's a small Y strainer here. We're going to take that out, we're going to clean it. If it can't be cleaned, you should replace it. It's very important because if you have any impurities that get into the valve, it can impede the seating of the valves. So we don't want that. So the next thing we're going to do is we're going to open the upstream isolation valve. So we've got a water supply again. And we're going to connect the high pressure hose, which is the red hose. By the way, all the valves on the test kit are closed at this stage. So the high pressure hose, which is the red, is going to go to test tap number 1. And the low pressure hose is going to test tap number 2. And the drain valve, which is number C on the test kit, should be open. So what we're going to do now is just bleed any impurities out. A and B are still closed on the kit. We're going to slowly open test valve A and B. And we're going to open valve A on the test kit. Bleed any air and impurities out. Close A. Open B. Flush that out as well. Close B. So now A and B are both closed. We're going to observe the differential pressure across the first check valve, or the upstream check valve. So we've got 11 kPa. It needs to be above 7 kPa. If it's not, then the valve needs to be serviced and repaired, and the test needs to be commenced again after you've done that. So I've got a solid pressure. It's actually 13 kPa, very sensitive gauge, but it's to the standard. Right, continuing on with our testing of this DCV, we're going to close test taps 1 and 2, and we're going to just get rid of any pressure that might be in the system by opening valve A and B and venting through the drain hose. So now close the valves off again. Let's see, can stay open. So we're going to disconnect the hoses. The next part we're going to do is the downstream check valve on this DCV. So the high pressure hose is going to go to test point number 2. The low pressure blue hose is going to test point number 3. And once again, A and B are closed, C is open. We're going to open test point number 2 and test point number 3. And we're going to once again bleed out any impurities by opening valve A, close A, open B, close B, and then we're going to observe the pressure across that check valve and wait until it stabilises. We have to have greater than 7 kPa. We have 10.7 kPa, so that implies that the second check valve is fine. It's got to be greater than 7 kPa. So the next thing we're going to do is close test tap 2 and 3, and then we're going to just relieve any pressure that might be in the system by opening valve A and B, then close A and B, disconnect the hoses, and we're just going to restore the valve to normal service by opening the downstream isolation valve. And that is this test completed.